Okay, you're given the first derivative of f, f prime. How many critical values does f have? So critical values, again, by definition, is when f prime is 0 or undefined. Okay, you need to memorize that. Critical values, f prime is 0 or undefined. So a couple places. The easiest thing to see is that this is going to be undefined when x is 0. So one critical point automatically from being undefined is x is 0. That's a critical value. The other time this is going to be a critical value is when f prime is equal to 0. So I'm going to do that over here. When does f prime equal 0? That's going to be when cosine squared of x over x minus 1 over 5 is equal to 0. This is a complicated function. To solve for x would be very difficult. Luckily, this is calculator active. So all we need to do is graph this function, find when it equals 0 on the interval 0 to 10. Okay, so function y equals cosine of x squared. So notice this, the parentheses are closed. If you don't have the parentheses, it'll mess it up. That's cosine times cosine divided by x minus 1/5. And I'm going to graph it from 0 to 10 because that is the interval we're interested in. Once you find the domain here, you can hit zoom fit, and that'll give you the proper range value for this domain. So you can see if we're trying to find when it equals 0, it's going to be equal to 0 a lot. And I don't know exactly how many times, so I'm going to zoom in so that I don't have so many y values. If you notice, you have all these wasted y values up here. Go to the window, it goes from -0.2 all the way up to 9. I don't really need to go up that high. I can go up to maybe just 1. So changing the maximum y value. Now I can focus on the x-axis to see how many times it crosses. You can see it's only going to cross 1, 2, 3 times on the interval 0 to 10. So it's going to happen 3 times. Oh, I'm sorry. Wait a second. So this has 3 solutions. X, there are 3 solutions here. And that's only for f prime equal to 0. But we also have this 1 over here. So in total I have 3 plus 1. I have 4 critical values. Good thing I read the problem again. So it is 4 critical values. Number 8, find the d over dx, d by dx, the derivative of this. Looks like it's going to be a mixture of rules. I'm going to rewrite this. I'm going to rewrite cosine squared as cosine x to the 3rd squared. So when I take a derivative of this, it'll be easier to see that I'm going to have to use the power rule first. Cosine of x to the 3rd. And then to the first power, subtract 1. But then I'm going to have to multiply by the derivative of the inside. The derivative of the inside would be negative sine x to the 3rd. But then again, derivative of the inside x to the third would be 3x squared. All of this multiplied together. None of these look exactly like that, but I'm going to rearrange a lot of this stuff. So to help you see what's being multiplied, I'm going to rewrite this with parentheses around everything. So the things that I can rearrange, I just have 2 by itself, and I have cosine of x squared is a thing by itself. This negative I can move to the front. Then I have sine by itself, and then I have 3 by itself, and then I have x squared by itself. These are all separate things. So what I can do is I can multiply 2 times 3, and that'll give me -6 because I have the negative from here. So I'm hoping it's one of these negatives, probably this one. So that takes care of the -2 and 3, and then I have an x squared also. So that's this and this. Then I have a sine x cubed, that takes care of that. And the last one, x squared, is that a squared or is that a cubed? That's a cubed. So that takes care of that. So the answer is D. If the second derivative, f double prime, is this, which of the following could be f? Okay, so you're given f double prime, and if you had to work backwards, what would f be? Usually we go this way. The only thing we've done so far is taking derivatives. We haven't gone backwards. So let's try to work backwards. Let's pretend, let's just look at this. Okay, so let's pretend I had if x squared if f was x squared minus sine x plus 1, what would f prime be? It would be 2x minus the derivative of sine is cosine, derivative of 1 is 0. Then take another derivative, you're going to get 2 minus, and the derivative of cosine is negative, so it would be minus negative sine, which would be the same thing as 2 plus sine. So it's not that one because it ends up with a 2 plus sine x, and I need a 2x minus cosine. So it's not that. So since the second derivative didn't have any x values, which I need an x value, it needs to be, every single time you take the derivative you lose 1 power, and so I lost any of the x values. It went x squared, 2x, 2. So in order to be left with a 2x, I'm going to need to start off with a higher power. I need to start off with a x cubed. So that means this one's also out of the case because that's not going to be good enough to end with a 2x. And that's where x cubed, and x cubed come into play. So looking at this, I'm going to need to figure out, well, is it x cubed over 3, or is it going to be x to the third? So let's pretend this was wrong. Let's pretend f is x to the third. Then f prime would be 3x squared over 3. The 3's cancel, and you get just x squared. And f double prime would give you 2x. So this looks like what I'm going to need. So x to the third is not going to work because of this. I'm going to need an x third over 3. So the other part, two different color. Let's try cosine. So it's in between, do I start with cosine or negative cosine? So let's try plus cosine. Take the derivative, you get negative sine. Take the derivative again, you get negative cosine. Because the negative sine, take the derivative, you get negative cosine. So you're left with negative cosine, which is exactly what I need. So the answer is going to be this one.